till now we have looked at functions like y equal to x square or y is equal to sine 3x plus x square. So basically y equal to something, and such functions we say y is a function of x. So these are explicitly defined functions. But there might be functions like, say for example, instead of y equal to x square, we could have y square equal to x. Now of course we can convert this into an explicit one. Say y is equal to square root of x. Perfectly fine. But there might be functions like this where y is all mixed up within x's. Say 5x square minus 7xy square plus 8y cube equal to a square. We can't really convert it into a function which goes some, y equal to. So we can't convert this into an explicit function. So such functions are called implicit functions. And we say that y is a function of x and y. That means it is a function of both x and y. And when we differentiate such functions, we call it implicit differentiation. Let's look at some examples. The rules of the game are same. The only difference is when we differentiate y equal to x square, we say dy by dx, and this becomes 2x. Now what if instead of y it is y square equal to x? We differentiate y square following the same rules as we would this one. Say for example, instead of x it was x cube. How would we do it? We would look at x cube itself. So that is 3x square. Then we have to look at x itself. First we are differentiating cubic function. Then we are differentiating that is 1. So similarly on this side as well we have to do that. So 2y times y itself, that is dy by dx. So dy by dx would be what? Dy by dx would be 3x square divided by 2y. Okay, let's look at another example. 5x square minus 7xy square plus 8y cube equal to a square. Now what will be the differential of this? 10x times the differential of x itself, which is 1. So we can ignore it. Now here 7 is going to be common. Now here we have to apply the rule. So differential of x times y square plus differential of y square times x. Plus 8 times 3y square dy by dx equal to, now it's algebra, just simplify it so that on the left hand side you end up with dy by dx. So 10x minus 7y square minus 7x to y would be 14xy dy by dx plus 24y square dy by dx equal to 0. Now these two have dy by dx, so let's take it common. So minus 14xy plus 24 is equal to, let's take these two to the other side. So 7y square minus 10x. Now we can take this to the other side. So dy by dx equal to 7y square minus 10x divided by minus 14xy plus 24y square, right? So now if we want to know the slope of this curve at say 1, 1, it's just a question of substituting 1 for both x and y. So at 7 minus 10 by minus 14 plus 24, which is equal to minus 3 by 10. Let's look at another example. Square root of x plus square root of y equal to 3. Just start off, you know the rules. So x to the power of 1 by 2, y to the power of 1 by 2 equal to 3. So 1 by 2 x to the power of minus half plus half y to the power of minus half dy by dx equal to 0. This becomes 1 by 2 root x plus 1 by 2 root y dy by dx. So dy by dx would be 1 by 2 root x times 2 root y. 2 gets cancelled. We are left with minus root y by root x. If we want, we can rationalize it or we can leave it as it is. Sin y is equal to x sin a plus y. You have to differentiate this. Don't panic. Just follow the rules. This would be what? Cos y. Just don't forget to put that dy by dx. That is the differential of y itself is equal to 1 times sin a plus y plus x times cos x plus a plus y times dy by dx. Remember, we have to differentiate this also. Okay, now what? Now we have to get the dy by dx to one side. So cos y dy by dx minus x cos a plus y dy by dx equal to sin a plus y dy by dx common cos y minus x cos a plus y equal to sin a plus y. So dy by dx would be equal to sin a plus y divided by cos y minus x cos a plus y. We can differentiate inverse trigonometric functions very easily. Say for example, y is equal to cosec inverse of x. Now which means we can say cosec y is equal to x. Just differentiate. What do you get? This would be minus cosec y cot y dy by dx equal to 1. So dy by dx would be 1 by minus 1 by cosec y cot y. Can be further taken minus 1 by cosec y square root of cosec square y minus 1. Now remember, cosec y is equal to what? Cosec y is equal to x. So minus 1 by x square root of x square minus 1. Of course, you have to remember that differentiating cosec will give you cosec times cot. Okay, let's look at another one. X is equal to e to the power of y plus e to the power of y plus e to the power of y, and it goes on like that. So think of it like this. X is equal to, start from here, and what does it mean? What is it? E to the power of y plus e to the power of y plus e to the power of y. That is nothing but x itself plus x. let's simplify this and say, let's take log on both the sides. So log of x is equal to log of e to the power of y plus x. Now this can be rewritten as y plus x log e. So log of x is equal to y plus x log e, and log of e is 1. So which means log of x is equal to y plus. Now let's differentiate this. If we differentiate it, what happens? We get 1 by x. So this will be dy by dx plus 1. So dy by dx would be 1 by x minus 1. 1 minus x by x would be dy by dx. So as you can see, implicit differentiation is not very complicated. Follow the same rules of differentiation for both x and, but you have to be careful. Say for example, here in this case, y square is equal to x. Now when you are converting it into this, remember this is going to be plus or minus. So y is equal to plus or minus root x. So this will introduce a little bit complexity in our understanding of the entire process. So it would be much more easier if we do implicit differentiation rather than doing this. Okay, that is one thing. Second thing is, if you remember here, I just mentioned that dy by dx of cosec is minus cosec y cot y. We may remember it, we may not remember it. So what do we do in such a situation? Very quickly you can derive it. Say cosec x or cosec y, this is nothing but sin y, 1 by sin y. Now do the differentiation of this using the quotient rule. So sin y times differential of the numerator, which is 0, minus 1 into differential of sin y, that is cos y, divided by sin square y. Now this becomes 0, so we are left with cos y. Now this we can write it as sin y sin y. So cos y by sin y becomes cot y. 1 by sin y becomes cosec y. So just within 3 or 4 steps, we were able to arrive at this derivation. So I think that's enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.